This is the first section of the chapter on the Poisson distribution, and by this point you should have already been introduced to the binomial distribution in your normal maths lessons, and there are some similarities, there are some differences, but like the binomial distribution, the Poisson distribution is discrete. It's a discrete distribution. Okay, so both of these distributions are for discrete data, which means that if we want to work out the probability between a set of numbers, we can add up those values. We need to do something if I want to work out the probability of something less than something greater than something. And just like the binomial distribution, we can use tables to find values. And also we can use our calculator. And we'll look at how we do that. And we can also use a formula to calculate its value. And you see the formula over here. So this is the formula that allows us to work out the probability for a Poisson distribution. So if I want to find the probability of x equal to a value, then it's e. You may or may not know what e is, but it's a number a bit like pi 2.718, and that goes on forever, minus lambda, and you've got lambda to the power x over x factorial, and lambda is what we call our parameter. Okay, so for the Poisson distribution, our parameter, we only got a single one, lambda. That's the value we use. Whereas for our binomial distribution, we had n and p, didn't we? They were the values that we used to answer a question. So you can see there are some similarities, there are differences. If we want to use our calculator to work out the Poisson distribution values, so first of all, we need to make sure we're in the right mode. So menu and then 7 for distribution. Press 7. Once you do that, you've got some options. Now you need to press the down arrow at the top there, those silver buttons, and then you'll see number 2 is Poisson PD, and number 3 is Poisson CD. So like the binomial, the Poisson PD we use to work out the probability when x is equal to a value. Yeah, so that's an alternative to using the formula. It does the same thing. Whereas the Poisson CD, that's a cumulative probability, and just like binomial, it gives you the probability up to and including a value. So if we want to work out the probability greater than a value, we need to do 1 minus, just like we did with the binomial. Right, so there's 3 questions here. Part A, I have a choice. I could use the formula if I wanted to, because it's equal to. Okay, so I could use the formula with lambda equal to 3. That's our parameter. Or I can use my calculator, and I just need to make sure that I pick that option 2, which is Poisson PD. And if I use my calculator, number 2, and then from there I pick variable number 2. So that says variable. I don't want a list, it's a bit like having a little table. And x is going to be 3, I type 3 in, and lambda is 2.1. And that gives me a value, and we normally give it to 4 decimal places, 0.9 1890. Okay, so a couple of things. Distribution answers like this, binomial distribution, Poisson distribution. Later when you do the normal distribution, it's sort of standard practice to give 4DP answers, because basically the tables are also in 4 decimal places. And what I didn't introduce to you at the start was the notation. So you know, with the binomial distribution, we had by or x, which is our random variable, is binomially distributed with n and p. Should have done this at the start really. With Poisson distribution, let's use a different letter, can be any letter there. PO for Poisson, there is only one parameter, and that is lambda. Okay, so that should have been the first slide really, but that's our notation. Yeah. Part B. So we've got the probability that x is greater than or equal to 1. So just like how we did binomial, because the tables and our calculators only give us greater less than, cumulative up to a value, we need to do 1 minus the other value, so that would be the probability of x less than or equal to 0, or you could just write the probability of x equals 0. That's the only number we're going to take off. And we could work this out by using the formula. Yeah, I'm going to use my calculator, so it's going to be 1 minus, and then I can keep on binomial PD actually, because it's only probability of 0, with x equal to 0, same value of lambda, and I get 0.1225 rounded to 4 decimal places. And if I wanted to keep it really exact, I can press menu, go back to 1 and do 1 minus answer. And I get 0.8775 for that answer, again 4 decimal places. And then part C, I'm trying to find a probability between 1, not including 1, and 4. So just like we would do with binomial, I'm going to find a probability up to 4, which I can use my calculator for. But I then need to subtract the probability, because basically I want just the probabilities of 2, 3, and 4. So I need to subtract the probabilities up to 1. Or I could say, write the probability of 0 and the probability of 1. I could do it that way and use the formula. But it's quicker probably to do this way. So if I now go back to my distribution, down arrow, I'm going to go to Poisson CD now, and it's a variable. So I find a probability up to 4, x is 4, lambda is still 2.1, and that is to 4 decimal places 0.9379. That's rounded to 4 decimal places, minus the probability of 1, so I'll just press AC and I can change x to 1, and that's 0.3796 to 4 decimal places. So if I do one of those minus the other, so I'll have to go menu and 1, so 0.9379 minus 0.3796, and I get 0.5583. So 0.5583. So very similar to binomial in the way that we work out these greater than probabilities or between a set of values. Okay, you should now be able to do exercise 2A. So just remember, this is the notation like this. And we have the option of the formula. If I want to find the probability of a single value, or you can use your calculator. It's probably quicker to use a calculator. Probably use the formula when we need to work out some problem solving questions where maybe we might need to work out lambda, and we know x, for example, we might need to work backwards. Oh, and just remember x factorial just means x times x minus 1 times x minus 2 until you get down to 0. So if it's 3 factorial, 3 times 2 times 1. Actually, I then put 1, you're going to finish at 1. So we've got formula, we've got tables. Now remember the tables, just like your calculator, when you use your calculator in CD mode, okay, both of those are going to give the probabilities up to a value of x, and if you've got your calculator in this PD, Poisson PD mode, that will give you the probability of a single value, which is basically what we get by using the formula up here. So we have choices. Okay, these are just some more examples here, and these are examples where we on the next set of questions we'd use the table. So this one here is very easy. So we've got all of these Poisson distribution with where lambda is 5, and we're trying to find a probability x is less than or equal to 3. So this is straightforward. We make sure that we are on Poisson CD, cumulative. Number 2 for a variable, x is 3, lambda is 5, and we get 0.2650 if it's rounded to 4 decimal places, part B. Still the same parameter, but now x is greater than or equal to 2. So we do 1 minus the probability that x is less than or equal to 1. So it's going to be 1 minus, so I can just press AC, make x equal to 1. So it's going to be 1 minus 0.40. Oh, sorry, I've missed the 0 out. 0.0404. Okay, so if I work that out, I need to go back to my menu, number 1, 1 minus 0.0404, and I get 0.9596. 0.9596. And the last one, C, still have Poisson distribution with a parameter lambda 5. We want to find the probability of x being between 1 and 4, including 1 and 4. So we have to find the probability up to 4 and take off the probability up to the number we don't want is 0. So you could either write less than or equal to 0 or probability that x equals 0, because that's only one value. So you could use the formula there if you wanted. So back to Poisson CD and variable. So x is going to be 4, lambda 5, and I get 0.4405 if I round it. And now press AC and change x to 0. Still lambda is 5. Alright, so this is in standard form. Okay, so 6.738, I'm trying to work out like 4 decimal places, times 10 to the negative 3. And if we work that out, go back to normal mode on my calculator, 0.4405 minus, now I'm going to write this in standard form, 6.738 times 10 to the negative 3, and I get 0.4338. So I probably had a couple more decimal places than I needed when I wrote this down here, but that works. Right, on this you'll notice that we have the probability, but we don't have the value of x. So here we're going to use the tables to help us, but we need to be careful with the greater one and the less than one in part B, B and C. So part A, probability that x is less than or equal to A is equal to 0.2414, and I can see that lambda is 7.5. So I'll find the table. I'm just going to turn to the table now. This will be in your formula book. And in the back of the book, there's a table for binomial and Poisson, so you need to be careful. So I'm looking for Poisson is 7.5, or lambda is 7.5. So on page 191, 1, 2, 3, 4, it's the fifth column in the lower half of the table, and I want to go down the table until I find 0.2414. Alright, and that's when x is 5. So the value of A is 5. That's easy. A is 5. So when you do the probability up to 5, it's 0.2414. Part B. So it says the probability that x is less than B. Now if that were a number, so if that was a number 10, the probability that x is less than 10, what would you do? You would do the probability of x less than or equal to 9, 1 less. So actually, it's less than or equal to 1 less than the number B. I'll just do an example here so you can see what it would be like if there were numbers there, and then you can see actually the pattern, what we're doing. So the probability that that x is less than or equal to b minus 1 is equal to 0.5246. Now what does that mean? That means when I look at the same part of the table and I find 5246 and it has the number 7 next to it, that means b minus 1 is 7. Okay, so b minus 1 is 7. So 7 was from the table for that value that I have there. So for this value, 7 was next to it in the table, but I've got b minus 1, so b minus 1 is 7. So all I need to do is to solve that, and I'll get b equal to 8. Struggling to solve that one. And then part C, the probability that x is greater than or equal to C. Now how would we do that? Well, we do 1 minus the probability that x is less than or equal to C minus 1. I'll show you what I mean. Here's an example. So if I wanted to know the probability that x was greater than or equal to 12, I would do 1 minus the probability that x is less than or equal to 11. Yes, like the previous one, it's 1 minus the value on the left hand side. So just like the previous one, we're going to solve this. Now that is equal to 0.3380. This now becomes an equation that I solve. So the probability that x is less than or equal to c minus 1, well, to do that, I need to do 1 minus 0.3380. 1 minus 0.3380. And I get 0.6620. 0.6620. So basically all I've done there is just solve this equation. Yeah, I've sort of brought this over that side, taken the decimal away from there to get that value. So going down the table, 7.5, I'm looking for 6620. Going across, I can see 8 next to it. Now it doesn't mean C is 8, it means that C minus 1 is equal to 8. So that means that C equals 9. Right, you should now be able to do exercise 2B on page 22 of the textbook.